All right. Let's see. We had a question on number, was it 18, John?
Yes.
Okay, so we're going to do number 18, and then the last one on the assignment was number 38. Is that right?
Yes.
Okay, so let's take a quick look there. So on 18, it's f of x equals square root of x plus 1, and g of x equals 3x. And what part of that was the trouble?
Just kind of figuring out how that really works. I don't really know very well.
Okay, let's do this one. Let's do part A, f. It's written like this. What that means is f of g of 4. So that means we start with this number right here. Start with that x. We're going to plug it into something. What are we going to plug it into? We're going to plug it into g. So the first thing we do is we take 4, we plug it into g. So let's see what we get out. What we'll get out is g of 4, and g of 4 is, well, if I plug a 4 into this one, the rule is 3 times whatever I plug in, so that's a 12. Okay, I then take that and I plug it into f. So that's going to be the square root of whatever I plug in, 12 plus 1, so that's the square root of 13. That's the answer. Okay, now we could actually come up with a rule for this. If I wanted to do f of g of x, that means I take x, plug it into g, so I get 3x. Okay, or I could just say I'm taking g of x, which is 3x, and I'm plugging it into f. That's going to be 3x plus 1. That's the rule. So this one says find f of g of 4. In some cases, it's almost quicker to do that. Wherever there's an x, what are we going to put? 4. So 3 times 4 plus 1, that's going to be the square root of 13. Same answer we got here. Okay? John, do you want to pick another one there? Do either C or D? D. Let's take a look at D. Okay, so D said this. D said it wants g of 0, or written another way, g of 0. So I'm going to take 0, I'm going to plug it into g. What do I get out? 0. So if I take 0, plug it into g, I get g of 0, which is 0. Then I'm going to take that and I'm going to plug it into g, so I'm going to find g of 0 again, which is 0. So that's the answer. It's a little bit of a weird one. Let me write the rule for this. So if we were to write the rule for this, g of x, that would be, well, take 3x and plug it into 3x. So that would be 3 times 3x, that's 9x. And what happens when you plug a 0 into this? You get 0. Okay? Same answer we would have gotten otherwise. Okay, let's take a look at problem number 38. Let's see. Charles, was there a specific part of 38 you wanted to look at? And can somebody tell me what makes this one difficult to do? It is one of the more difficult ones. Why is it more difficult? Yeah, they're both fractions. Okay. They've got variables in the denominator, so they both have domain issues, so that's a little bit tougher. It says, find the domain of the composite, let's see, f of g, g of f of f, g of g. Okay, so this is very similar to what we did in the notes. Okay, we did one almost identical to this. It wasn't exactly the same, but it was pretty darn close. Charles, you want to pick one? Okay, let's do D. D says find g of x and state the domain. So that means g of x, right? That means we're going to plug g into itself. So that would be g is -2 over something. And what is that something that we're plugging in? -2 over x. Okay? Now remember, you've got to throw out anything that doesn't work with the function you're starting with. So we've got to throw out 0. So x cannot equal 0. And then we simplify this and we see if we need to throw anything else out. Okay, so I'm going to flip this over and multiply. So this is going to be x over a negative 2. So now I can cancel those, cross cancel those, and the answer is x. That is the simplified answer. Do I have to throw anything else out in the end? Nope. Okay. The only thing that doesn't work here is 0. Okay. So that's the new rule. That's the composite function, and that's the domain. Plug in anything you want but 0. Okay. Let's see. How about we do C? C is f of x. So what gets plugged into what? F gets plugged into f. So f is 1 over something plus 3. What is that something? 1 over x plus 3. Okay. We just took f and plugged it into f. Okay, then we need to simplify this. So what I'm going to do is I'm going to get a common denominator on the bottom. This should look really familiar. This is 1 plus 3x plus 9 over x plus 3. So I've got a single fraction on the bottom. It's 3x plus 10 over x plus 3. So if I have 1 over 3x plus 10 over x plus 3, and I take that and I flip it over, what do I get? I'll write that, x plus 3, 3x plus 10. You get x plus 3, 3x plus 10. That's it. What do we need to throw out? Negative 10/3. Is there anything else we need to throw out? Okay, remember where we started? We started with f. Is there anything you can't use in f? How about negative 3? Okay? That should look really, really familiar. Okay? All right. Any questions? Okay, let's pass that one person to your left. Okay? 3, 4, and 3, 5, one person to your left. Okay, on 3.4, what was the first problem on the assignment? Was it 1? Oh, you had to do 1, was it 1 through 19? Yeah. Okay, 1 through 19 odd. And then you also had to do like 29, 33, 35, 36, 40, 41. Was 41 the last one on the assignment? No, we had those on the other page. 60, 59, and 60. Yep. So check and make sure they got those done. If they got done with the assignment, give them 3 points, and then we're going to find problem number 36. Here's problem 36. It says f of x equals x plus 2 quantity cubed minus 3. And let's see, the instructions were graph that. And we'd want to label a couple of points. So this is going to be the cubing function. It looks like this. It goes through 0, 0, 1, 1, and negative 1, negative 1. Okay, the next most convenient point would be like 2, 8, negative 2, 8 down here. We're going to take that graph, and what does the plus 2 do to it? Okay, left 2. And what does the minus 3 do? Down 3. So we're going to take that graph and we're going to move it 1, 2, 1, 2, 3. So we're going to move it down here. It's going to look exactly the same, but we need to label a couple points so we can convince people we know what we're doing. So they should definitely label that center point, okay, what used to be at the origin. So that's going to be negative 2, negative 3, and then probably label 1 on either side. I normally go over 1 and up 1 cubed, so that point right there should be, if I go to the right one, that would put me at negative 1, and if I go up 1, that would put me at negative 2. Okay, this point right here, if I go to the left one, that would put me at negative 3, and if I go down 1, that would put me at negative 4. Another point they could graph would be, well, let's see, where would this cross? Go over 2 and up 8, so this is going to be 0, 5. And this other point down here would be -5, comma, let's see, if I go back 2, I normally go down 2 cubed, so I'd go 8 more, so this would be -11. They don't have to have all 5 of those points, but they should have probably at least 2 points graphed and labeled, okay? One if they did it, one if they got it right. Okay, so 5 points altogether on that one. Any questions there on 3, 4?
They didn't label the points.
If they didn't label anything, then let's call it a 4.5. They got everything else done? Okay. Okay, let's take a look at 3, 5. And on 3, 5, find, let's see, the last problem on the assignment was 38, right? There were about probably 15, 18 problems there. Find problem number 28. 28 is f of x equals x minus 2, and g of x is square root 1 minus x. And it says find this composite, f of g of x, or in other words, f of g of x. So what gets plugged into what? What?
I don't think we did a problem.
You didn't do 28?
No.
Did you do 24?
25.
That's weird. I have that marked. Okay. All right, let's look at 25 then. Okay, so here's 25. F of x, I'm just going to erase this. 25. Mm-hmm.
They get 3 points if they finish the whole assignment.
Yep.
And so what if they didn't do the entire assignment?
Yeah. Well, give them something less than 3. I mean, don't give them a 0 if they got most of it done. Okay. So on 25, it's x over x minus 1. And they've got to have the work for this, otherwise that's no good. Okay. And it said find f of g of x. So that means we're going to plug g into f. So f is something over something minus 1. And what am I plugging in for that something? That guy right there. We're plugging in the g. So -4 over x. Okay. I don't know anyone that can do this without doing this work. Okay. I can't do this without doing this work. So if they have the right answer, but they don't have any work shown, they don't get credit for this. Okay. So what we do on this one is we'd get a common denominator. So this is going to be -4 over x minus x over x. So this is -4 over x over -4 minus x over x. Then I'm going to take that bottom one and I'm going to flip it over and I'm going to multiply. So this is going to be x over -4 minus x. Okay, so we've got a factor of x on the top and bottom that can cancel. And I've got a -4 over -4 minus x. Okay, now you could leave it this way. It would be better if we factored a negative out of everything. So we wrote a -4, we wrote a -x plus 4, and then canceled those. So this would be 4 over x plus 4. If they wrote that and they don't have any work, that's very strange. What number can we not plug in here? Right here? Okay, -4. And what did we start with? We started with g. So what else do we have to throw out? Okay, make sure you throw out 0 also. That right there is the answer. Okay? 3 if they got done with 3.5. 1 for doing 25 as long as they have work shown. If they don't have work shown, they don't even get that point. Okay? And then 1 for getting it right. Okay, so give them a score out of 5, pass that back. And then if you take out your notes from 3.6, did anybody look at the assignment? I said you could probably do the stuff that had like rectangles and circles and triangles and stuff. Okay, can I get rid of this up here, or do you want me to leave it? Okay. All right. Let's see. Score on 3-4 and 3-5. Nathan.
Oh, I got 3 on 3-4, and then I didn't.
Okay. Susan. Alyssa.
5 and 0.
Josh.
5 and 5.
JC. Amanda.
5 on 3, 4 on 3.
Charles.
4.5 and 4.
Shelby is not here. Alex.
4 and 0.
Caitlin.
5 and
Kirsten.
5 and 0.
Colin.
4 and
Tatum. She's not here either. Ira.
4 and 5.
John.
5 on both.
Good. Kylie's not here. Josh.
4 on 1.
Kang.
5 and 4.
Chase.
4 on both.
Shane.
2 on both.
Samantha.
3 and 4.
Lupe.
5 and 4.
Emily.
4 and 4.
And Max.
5 and 4.
Okay. Let's see. So we are about 3 weeks or so in. We got our first test on Monday, right? Okay. And I showed you, I think last time, you go to the website, College Prep Reviews. Right here, here's the review for Exam 1 if you want to get started on it. It's got a description of everything that you'd need to be able to do, and if we just read through this, find the slope of a line when given 2 points to the equation. Pretty easy. Write the equation of a line in point-slope form or slope-intercept form. Pretty easy. So if you start reading this list, it's pretty easy stuff up until we get to 3.4, 3.5. Big difference there, isn't it? Okay, just like any math class, 1050 will start out with a little bit of review of some, Algebra 2, 1010 stuff, and then it gets right into it. So if you kind of hit a wall in 3.4 and 3.5 and 3.6 if you tried to do the homework, the same thing is going to happen in 1050. So if you thought, hey, these first 2 weeks, these were pretty easy. I'm in good shape in this class, okay? This is 1050 material, okay? And you're not going to see much that you recognize from here forward. Couple things here or there, but this is going to be new material unless you've already had pre-calculus, okay? So sitting by and watching the homework, it's due, but I'll just use a late assignment or something like that. That might be okay for 1 grade on 1 assignment, but it's not going to change your grade in the class. Okay? So make sure you stay on top of things. If you've got a question, please ask the day after it's assigned, because you would have gone home and worked on it that night, tried to get it done, and you know what the issues are that next day. Okay? So there's a description of what you'd need to know how to do, and there's a bunch of review problems. Okay, you won't be able to use a calculator on this exam that's coming up. Everything relatively easy numbers. Okay, we're testing the ideas there. Okay, so that's where you can find that. Just go to the website, download that. You can get started on it. That's what you should be working on tomorrow in class and asking questions on tomorrow in class. Got it? Because the test is Monday, right? Yeah.
Are we turning it in?
Yes, it's for points.
So it's still on.
Yes, do before you take the test. Okay. Any other general questions? Yeah.
Can we just get to that site on our email?
You can just go to the school website. So if you go, let's see. You can Google my name if you spell it right, or you just go to the Itinerus website, hit Contact Us. And under Contact Us, there's all the teachers' websites and email addresses. If you just click on my name, not my email address, you get right there. And it's just under College Prep, the very last thing, last category, College Prep review assignments. Everybody got that? So that you can consider that assigned today. Make sure you print that, bring it tomorrow. Bring your books so that you can work on that, bring questions. Because when you walk into class on Monday, it's sit down and take a test, yeah.
Do you have a stapler out there?
Nope, I think we just take that back. Yes, I do. Yep. Sure. Okay. Any other general questions? Okay. All right, so let's go back here and take a look at, let's see, we were doing this problem right here. It said express the distance d from point P to the point 0, -1 as a function of x. So that's basically saying how far is it from 0, -1 to x comma y, no matter where this point is on here. So we did it like this, okay? But it could have been up here, and we could have had to find that distance there. It could have even been over here, okay? Find the distance there. Okay, something like that. This will give you the distance no matter where you are, and we wanted to clean this up just a little bit. So we would do this. We'd write d of x equals square root of x squared plus x squared minus 7 quantity squared. That's probably good enough. If you want to square things out here, you'd get x to the 4th minus 14x squared plus 49. And then there's this x squared here, so you'd get a big square root, and x to the 4th minus 13x squared plus 49. You could do that if you want, but there's not much need. It just said find an equation. That's a reasonably simplified equation or function. Okay, and then we talked about this next part. What does it mean if find the distance if x is 0? What do we do to find the distance? Yeah, you plug in 0 for x. We found a function that gives us the distance between these points if you plug in what the x coordinate is, and it will spit out the answer. By the way, how far should it be from this point, which is at 0, -1, down to this point right here, which is where it is at 0, -8? How far should that be? It better be 7, and watch what happens when you plug in a 0. This is a 0. That's a 0. So this is 0 plus, what's -7 squared? 49. So it's the square root of 49 is 7. Does it spit out the right answer? You bet it does. Okay? And then it says if d equals -1, so we'd be finding the distance about from here to here. Okay? Probably a little less than 7 because it went up just a little bit. So we'd plug in a 1, so we'd get the square root of 1 squared plus 1 minus 7 quantity squared, so that's going to be 1 plus 36, that's going to be the square root of 37. 1 minus 7, -6, square -6, you get 36. Everybody okay with that? Okay, so that would be the answer to that one right there. Use a graphing utility to graph this. So let's grab our calculator. Okay, and we mentioned this yesterday. So this says y, but we're thinking the y-axis is now what variable here? D for distance, right? Okay, and this is still the x-axis, so we're in good shape there. So however you want to type it in, I don't care. I'm going to do this one right here that we have circled. So this is x squared, and then it would be plus parentheses x squared minus 7, close the parentheses, square that, and close the parentheses again. Make sure you use the right amount of parentheses, especially when you've got this quantity that's squared. Any questions? Okay. Let's see. Distance is always positive, right? So do we need to use any negative values for the distance, for the y-axis? No. That's actually not too bad right there. We probably ought to do some negatives. Tell you what, let's do this. Hit zoom, 6. Just the standard window, -10 to 10. What? Let me slide this over. Okay, this is a pretty big distance, but as I go here and here, it gets smaller. Pretty big distance, go on either side. The distance is smaller on either side. It probably would be the smallest about right here. Okay? So that's what that point right there would be. It says, for what values of x is d the smallest? How do we find that again? Find the minimum. So you hit second, calculate. We'll go minimum. Left bound, we're good with that. Again, if you don't want to use the cursor arrows and do that, which is a pain in the butt, let's count 1, 2, 3, 4, or 5. That definitely would be on the other side. So I'm just going to type in 5 and hit enter. Okay, so notice it's got the arrow for a cursor here, arrow for a cursor here. So we're finding the minimum on this interval right here. It says take a guess. If you want to take a guess, I'm going to type in a 3 for the guess. It's going to work for a bit, and it should find this point right here. So the minimum is at x equals 2.549, and the minimum is 2.598. Pretty close numbers. I think that's a bit of a coincidence. Okay. Which is the answer, the x or the y? The x or the d? It is the x. So the answer to this one is 2.5, was it 49? Is that what it was? Okay. All right. Any questions? Sure? Okay. Raise your hand if you started the homework. You went home, you read 3-6, looked through it. Okay. Let's just have a chat here. Why not? Up until midnight doing the rest of your stuff. You were doing what? Oh, how I Met Your Mother. Very nice. Okay. Do you have a test today? How many of you have a test today? All right, I can buy that. Okay. But this won't go away, so please don't ignore it. If you do have a test on, or when something like this happens, at least browse through and look at 1 or 2 problems, just so you familiarize yourself with it. Okay, your brain will actually work on it while you're sleeping. Okay, you'll come here in better shape to figure things out the next day. Okay, if you've put some work into getting that into your head, let it cook for a while. When you come the next day, it'll make a heck of a lot more sense if we go over some problems. Okay, so are there any questions on this problem right here? Okay, let's take a look at the next one. Okay, it says 2 cars leave an intersection at the same time. One is headed south at a constant speed of 30 miles per hour, and the other is headed west at a constant speed of 40 miles per hour. Express the distance between the cars as a function of time. At t equals 0, the cars leave the intersection. So here's what's happening. We've got a diagram here. It shows this one heading that way and this one heading this way. So if we let a couple minutes go by, this one's going to be over here and this one's going to be down here. The distance between them would be this right here. Does that make sense? Could everybody draw that diagram if they had to interpret this question? Okay. What type of triangle is this? It is a right triangle. Okay. And again, I was mentioning yesterday, sometimes it can be good if you just kind of take a time out and, just look at a diagram and forget about the problem right here. What do you know about right triangles? Sides of right triangles?
Using a squared plus b squared equals.
Okay. And what is that called again?
Pythagorean.
Pythagorean theorem. Okay. So if I say this is x, let's call that one x, and I'll call this one y, because this is horizontal and this one's vertical. And I'm going to call this one s. Okay. We'll tell you what. Let's call it d, because that's the distance, right? So a formula that relates these would be d squared equals x squared plus y squared. This one says express the distance between the cars as a function of time. Okay, this is a distance in this direction right here. Okay, the one that's heading south is going 30 miles per hour. So this one's 30 miles per hour. This one's 40 miles per hour. What's that formula that relates distance, rate, and time? D equals RT. So how could we represent how far this one is able to go in a given amount of time? Let's say I gave it 2 hours. How far would it go in this direction? 80, right? Let's say I gave it a half hour. 20 miles. If I gave it an hour, this would be 40. Well, how are you finding those? You're taking 40 and doing what with it? Multiplying it by
Oh, time.
the time. You're taking 40 and multiplying it by whatever time I give you. So a better way to represent this would be, instead of an x, let's call this 40t. And instead of calling this a y, okay, so I'll put the x back here and the y back here. Instead of calling this a y, what else could we call this? This would be 30t. So what don't we like about this again? Two variables. But look, in place of the x, what can I put? I can put a 40t. So this is going to be a 40t squared. In place of the y, what can I put? A 30t. Whoops, I need parentheses around that, don't I? Okay, because I substituted. Okay, now, I really don't want the distance squared. I want just a plain old d, right? So couldn't I say d equals the square root of that stuff? Does that make sense? Okay. So here's what I've got. D equals the square root of, this is going to be, well, let's see here, 1600 t squared plus 900 t squared. Those I can put together. So that's going to be the square root of 2500 t squared, which is, what's the square root of 2500? 50. And the square root of t squared is t. So this is d of t. So out of that ugly problem, we end up with a distance formula or a distance function that's just 50t. It's the nicest one we've come across. Okay? So the answer to this one is d of t equals 50t. Okay? Any questions there? Okay. Good? Okay, watch. Let's say that I have the exact same problem, except for this time, this one got a head start. Let's say it was 1 mile ahead. So it started right here at 1 mile, and then it's still going 40 miles per hour. Okay, and this one started here, and let's give this one an even bigger head start. Let's give this a head start of 2, and it's still going 30 miles per hour. How would we represent how far it is from here to there? After like an hour or 2 hours or something like that? What's that?
X minus 1,
No,
t minus 1.
no. It's going to be a plus. Okay?
Oh, yeah.
We started out with 1 mile, and then all we're doing is just adding to it. So if this was 40t before, this is going to be 1 mile, that's the head start, plus 40t. That's the distance. We started off with 1 mile, and just like before, we add 40 miles per whatever unit of time. Okay, what's this one going to be? This one's going to be 2 plus 30t. Yeah. Question?
Well, I was going to ask what the 50t represents.
So back to the other problem. So let's leave this for just a second. It represents the distance between the cars. Okay.
Yeah,
So,
whatever time. It's
whatever time. Yeah, you plug in 2 hours, it'll tell you they're 100 miles apart. Does that make sense? But if we give each one of them a head start, it's going to be different. So this one's going to be 1 plus 40t. This one's going to be 2 plus 30t. But the formula that relates those was still the same. It would be square root x squared plus y squared. What do we do with the x and the y? Replace them with these guys right here. So this would be 1 plus 40t quantity squared. And this would be 2 plus 30t quantity squared. Now, is that one going to simplify as well as the other one did? Nowhere close. Okay? So this is a harder problem, but the idea is still the same. All we did is we gave this one a 1 mile head start, and we gave that one a 2 mile head start. Okay? All right. Any questions? Okay, that's it. Okay. When is this due? This is due on Monday. What else is due on Monday? The review. What are we doing tomorrow? We're working on the review, answering questions, making sure that you're ready to take that test on Monday. Okay? All right. Any questions? Okay. Go ahead and get busy on that. Here's the assignment. It's these problems right here. So I think there are 8 or 10 problems altogether. And I think we've done one of pretty much every type, although a few you might have to think for a bit. Okay?